Hey everyone, a friend of mine was recently giving the Amazon OA or the online assessment, and I found two of the problems really nice, and I'm sharing them with you in a single video each. Make sure before looking into my solution, you try to solve these problems on your own. And without any further ado, let's get started. Let me just change the view. Let me play some music. Okay, yeah, this is good. Okay, let's get started. So, the first problem. Not sure what the name is. I'll just call. So this for this video we have. Let's say we are given two things. Again, there's a lot of English in the problem statement, but I'm going to ditch that and directly discuss what is given, what is asked. So you are given an array called centers. For example, let's consider the case. The values are. Let me just confirm the. Yeah, -2, 1, 0, and D is given as 8. So what does this mean? Let's say we have a number line. This is 0, this is 1, this is -1, this is -2, and yeah. So we want to find out the number of points from where we can go to each of these centers and come back, and the total sum of all the distances from the given point should be less than or equal to D. What I mean by that, let's consider a case. Let's consider the point 1. What are the centers? So let's say from 1 we go to -2. So 1, say -2. The distance is 3, right? And then we come back. So we have to go and come back. So that will be a total of 6 distance. So from 1 to go to -2 and come back, we have 6 distance. Then from 1 to 0, the distance will be 1 minus 0, which is 1 times 2, which is 2. And from 1 to 1, the distance is 0. So total distance is 6 plus 2, which is equal to 8, which is less than equal to D. Hence, 1 is a possible correct value. Let's check for something like -1, for example. -1, if we start with -1, let's say, -1 from -2 will have 2 distance units going and coming back. -1 from 0 will have 2 distance units going and coming back. So this is 4 till now, and -1 to 1 will have 4 distance units going and coming back. So that will be 4 plus 4 less than equal to D. So this is right. So we have found out 2 points, which is 1 and -1. Now these points they do not need to be necessarily in the centers list. We have to find out maximum number of points that satisfy this condition. What is the condition? That for all points I, point I, distance of I, sigma, distance of I from distance of I comma j for all centers from j equal to 0 to n, distance of ij, sum of this should be less than equal to D. This is the condition that we have to solve, right? Take a moment, understand the problem, and think before you jump to the next point where we will discuss the solution. Pause the video here and try to understand. If it's not clear, just look at the video section above. It's still not clear, drop a comment. I'll maybe do something. But yeah, before diving into the next section, make sure pause the video and think, how will you find out all the points, the number of all the points that solve this given condition. In our case, for this example, the answer is 3. The possible numbers are 1, -1, and 0. These are the possible numbers and only possible set of numbers. And again, just to tell you the constraints before you jump. So constraints, we have so the length of the centers array, let's say n, is 1 to 10 power 5. The value of D can go from 1 to 10 power 15. Okay, and the value of centers of I can go from -10 power 9 to 10 power, right? So huge constraints on D here, so make sure you think appropriately. And now is the time for you to pause the video and think about the solution. Alright, let's discuss the problem solution now. So let me just solution. I don't know. The moment I looked at this problem, this looked to me very much like a binary search problem. I'm pretty sure there might be other methods to solve, although I'm not sure because of the huge value of D. But if someone comes with a solution without binary search, make sure you put that into comments. I'll be happy to take a look at that. Let's see. So the idea here that I have is, let's say this, consider this example, -2, 1, 0. Okay. The farthest point that I can have from the leftmost center, this is already sorted, is this minus D by 2 distance, right? So D is 8, so I can have here, so I can consider points between -6, -2, 1, 0 and 0 plus, what is D? 8, so it's 4. So my solution space, the points that will be in my solution will range from -2 to 4, right? There are no other points possible. If I go beyond -6, there's no way I can keep the distance, the sum of distances, as less than equal to D. Why D by 2? Because I have to go and come back. So again, the problem now reduces to finding the set of numbers in this integer space which satisfy the given condition. Okay, so far so good. Now, there would be one number for which, the first number for which the answer would be true, right? So again, let's say we try with -6, no, -5, no, -4, no, -3, no, -2, no, -1. Okay, I get a solution here. 0, let's say I get a solution here. 1, I get a solution here. Go to 2, no solution. 3, no solution. 4, no solution. So what I'm saying is, again, this is a monotonic function. It's like monotonic, or you can say that, if you have series of false, then a series of true, and again then a series of false. And you're trying to use binary search to find out the first point where it becomes true and the first point where it becomes false. Kind of like lower bound and upper bound. This is the idea that I used to solve this problem. So again, this is another chance. You can still pause the video and think how we would solve this problem by using the concept of lower bound and upper bound. So you can pause the video and continue. I'll continue. So what will be the time complexity then? So this overall array is length n, the sequence is length n again, or n plus d by 2, so it will be n again anyway. Or we can do, so this will be n times log of n, basically binary search. So every time we look a number, so what we'll do is, so how it's n log n, let me just maybe tell this. What we do is, we go, let's say we have -6 to 4, right? So dry running, what will be the midpoint of this? -6 plus 10, right? So 5. 1 will be the midpoint, right? 3, no, right? 4 from here, 6 from there, 0, -1, yeah? -1 will be the mid. We will check for -1, okay? We'll check for -1, and let's say for -1, the answer is, it's satisfied that the condition is less than equal to D. We move towards the left of -1. So we found one solution. We want to go towards, check if there's a solution on towards the leftmost side, possible or not. That will give us the lower bound. How is the time complexity here? For getting a number is in log n. Every time we half the search space. For each of this log n, I'm going to do a computation over the centers array and find out the distance of this current point. So that will be length of centers, which is n, so n time. So in each log n step, for each step I find in the binary search, I'm going to loop over the centers array and compute the distance sum twice of that distance. If that is less than equal to 2, this point is fine. So now on to writing code for this. Okay, I'm gonna write this in Java, so I'm gonna do new. Again, I'm not having much experience writing Java right now, but I'm still gonna attempt it in Java, why not? So let's create a new package. I'm gonna say all that shubham dot Amazon, let's say. Call it problem1. Okay, let's create a main function, and then we'll create a function called public static solve, which will take int centers and d, long d. Okay, public static, again the habit of TypeScript, right? Not being able to okay, I'll make the return type as long as well. There are a lot of numbers, and okay, I'll define two functions here. So private static lower bound, which will take these numbers and d, and it will return an index. Okay, and then we have private static int upper bound int centers long d. Okay, and so the idea is basically to find the lower bound, upper bound, find the difference between these two indices. That's our answer. Okay, so lower bound, upper bound, this looks good. Okay, so now int mid equal to, so we can define int left equal to 0 and right equal to, so again, do we start from 0 or should it be the minimum in the centers array? So again, okay, I'll have to loop here and find the minimum and the maximum. So I'll do, so what I will do is I will take this as an argument. So int min, int max here as well. I can int min, int max. So these are the minimum max element in the array. What we'll do is we'll do for int I equal to 0, I less than centers dot length plus let's keep underscore min equal to integer dot max value underscore max is equal to integer dot max value, and we'll do if, okay, so underscore min is equal to math dot min of centers of I comma underscore min. Similarly for max, I'm going to do math dot max of centers of I comma underscore max. Let's correct this, and then after this loop we'll call lower bound. So left is equal to lower bound of centers comma d comma underscore min comma underscore max, and then similarly for right I'm going to do very simple upper bound, spelling mistake, upper bound d min max, and then I'm going to return right minus left. Okay, this should be the solution. The only thing is, okay, what if the answer, there could be cases when no answer is found and my upper bound and lower bound might not return the correct value. So I'll return math.max of 0 comma right minus left. Yeah, this looks good. Okay, so left will be then min and right is equal to max. Mid is equal to right minus left by 2. Okay, then what we need to do, while left less than right, we need to mid here, while left less than right. Python habits. Okay, so int mid is equal to this, and let's say we return left here. Okay, so that this doesn't complain anymore, and we'll say, so distance of the current point will be, so long distance, equal to, so I need to write another function here to find out the distance. So we'll do one function here which will be, let's call it private static int find long, find the distance. So this will take the centers array and the current point and an int point, and for int I equal to 0 I less than centers dot length I plus plus, this will calculate math dot abs of centers of I minus point. Okay, and then long distance equal to 0L, and then we'll do dist plus equal to this, and we'll return this 2 times dist because you have to go and come back. Return 2 times distance. Yeah, this should be fine. And then we can do dist find underscore distance of centers comma mid. So now if dist is less than equal to d, then we have found a valid solution. So in that case, since we are calculating the lower bound, we will set right equal to mid and look towards the left. So otherwise else we need to go again towards the right to look for the first value, which is right. So left mid plus 1, and yeah, this looks fine. Similarly, we'll populate the logic for upper bound as well. So here as well, int left is equal to min, int right equal to max, while left is less than right. So we'll do mid is equal to, again, int mid is equal to right minus left. I think instead of int I should use long here because d by 2 can be huge, right? Long mid, right? Okay, long mid. Okay, and here as well I'll change it everything to long, and change this to long as well. Long. Okay, everything's long now, and then we need to find out distance. I'll copy this code from here. Find distance. Okay. So if distance is less than equal to d, or we should use the condition to yeah, this should probably be fine. Yeah, if distance is less than equal to d, we need to do left is equal to mid plus 1 as right equals to mid. So in this case, if distance is less than equal to d, we need to start towards the right side, so my left becomes mid plus 1. Otherwise right is still constrained towards mid. We need to go towards left. Yeah, this is fine. Return left. Left is long. Yep, long. Okay, let's see. Long this. Let's give this 0 as well. Let's test this. So this is good, right? Our distance is here. Okay, let's test this out. So I'm just gonna get some test cases. So I'll call s out solve of int minus 210 comma d is 8. Yeah, let's run this. Looks like some kind of an is it an infinite loop? While left is okay. Looks like we might be having an infinite loop. Of course, left and right are same, right? I mean not the same, but yeah, the range is wrong here. So what we'll do is we'll do min plus d by 2, right? So we'll have to do min plus d by 2 because we want to go towards the left, so it will be min minus d by 2. Min should also be long, so everything should basically be long. Let's not long here, long this is also long. Yeah. So min minus d by 2, max plus d by 2, and here as well we'll have max plus d by 2 as we discussed, right? The range is from -6 to 4, so min minus d by 2, max plus d by 2. So okay, 1 plus 4, here it should be 5. Yeah. Okay, let's run this again and let's see. Okay, it's again stuck in an infinite loop. Okay. Let's debug this then. I'm making such silly mistakes. Of course, it's left plus right by 2. Why am I in my mind right now? Okay, let's see. Okay, so that's one problem that we fixed. Another problem is okay, max will be min value, right? Let's check this now. Okay, one more problem solved. Okay, let's just debug this here and let's run this then. So we have, mid goes to 0, mid is -3, mid is -1, and then left and right are -2, -1, left and right are not updating. Okay, stuck at right equal to mid minus right equal to mid every time. Okay, so that means something's wrong with the division here, right? Let me just try with the bit shift instead of. Let's run this now. Oh yeah, it runs, and 3 is the answer, right? Let's just check one more case to validate. I have one more test case. So this is -3 to 2. We'll have S out. Let's put this here. Solve new int. We have -3 to 2, and then we have D as 8 again. So for this one, I guess there's no valid answer. Let's check. Do we get 0? We get 0. And there's one more. Let's test this out. So we have, let's say, 50, 100, 150. And D should be 200. Only one should work, should be 100 as the center, right? None of them should work. Let's check for larger inputs and see if this breaks or not. So let's see. 2, 3, 4, 5, 6, 7, 8. Let's say 1, 2, 3, 4, 5, 6, 7, 8. Let's give this 1, 2, 3, 4, 5, 6, 7, 8. Yeah. L. Okay, yeah, this is the answer. Okay. No way to validate it because brute force won't work, but yeah. So this is the solution. Okay, yeah. That's about this problem. I hope you guys enjoyed it. Sorry for the hiccups while programming this. Again, as I said, I'm being honest, I'm not doing Java regularly right now, but hopefully soon I start doing Java again, and then I'll probably get my hands dirty with Java again. And again, I hope you enjoyed solving this video. Uh, what am I saying? I hope you enjoyed solving this problem. And if you really did, make sure you give this video a thumbs up and subscribe to the channel if you haven't already. I'll see you guys in the next video. Until then, take care. Bye-bye.